Have you ever wondered how Spotify guesses which songs will cheer you up, or how that navigator finds the fastest road? All this at the span of AI. AI learns just like a child, by watching, analyzing, and improving. These systems take our experiences, process them, and give us results. And honestly, can you imagine that your life without them? But how does this happen? Imagine that you are teaching a child to distinguish between different fruits, such as apples and oranges. At first, you showed him many examples, a few apples and a few oranges. Every time a child points to a fruit, you say if he guessed correctly. If he's wrong, you explain what the difference is. Over time, the child starts noticing what makes each fruit unique. Soon they can tell them apart. No help needed. First, we start to collect a lot of examples, for instance pictures of apples and oranges, each of which has a label, apple or orange. This data serves as lessons for the model. The model looks at these examples and tries to determine what features, color, shape, texture distinguish apples from oranges. It remembers them using mathematical algorithms. After the model tries to guess which fruit is in the picture, we compare its answer with the correct label. If the model is wrong, the algorithm adjusts, similar to how you correct a child by pointing out distinguished features. This process is repeated many times with different examples. Over time, the model begins to make fewer mistakes and learns to correctly distinguish fruits even in new, previously unseen images. Training an AI model is like a pitching step by step. It learns from tons of examples, fine-tunes itself, and gets better at giving accurate results over time. Interestingly, this process actually resembles how we learn from our own experience. We try, screw up, analyze mistakes, and eventually become better. Let's dive into something more complex. The road isn't just about picking from a few options. We often solve problems with many variables and possible outcomes. Think of teaching a child to make the perfect sandwich. At first, they randomly add butter, cheese, and ham. After the first bite, they realize it's not quite right. So they tweak the recipe. Less cheese, more ham. With each taste test, they fine-tune the balance until it's just perfect. That's exactly how parameters tuning works in AI training. It all starts with the initial parameters, which is still far from perfect. Now the model makes a prediction using these parameters. It might try to recognize a fruit in a picture or predict a stock price. But here's where things gets interesting: the error score. The model's result is compared to the correct answer. If it's wrong, there's an error that needs fixing. It's just like when a child takes a bite of their sandwich and realizes, not quite right. Time to adjust. The model then adjusts the parameters so that the max prediction makes the error smaller. This process is called gradient descent. The model descends in the direction of decreasing error, like a traveler looking for the easiest way down the mountain. And this is how repetition occurs. The model repeatedly adjusts its parameters until it learns to give the correct answers almost always. Just like a child who prepared the perfect sandwich more and more accurately every time. Now that we've seen how the system learns step by step, let's talk about the role of mistakes. Errors aren't just failures, they're part of the learning process. Just like the child who misnames a fruit and then correct themselves. AI models adjust based on their mistakes. Let's explore how these errors actually help the model grow and improve over time. Let's go back to our fruit example. You show a child apples, oranges, and pears. At first, they leave them up. They haven't learned the unique features yet. But these mistakes? They're not failures, they're part of the process. Every mistake is a chance to improve the model of AI. Just like the child learns from experience, and a model does the same, adjusting, refining, and getting more accurate over time. In fact, the more mistakes it makes, the faster it improves. So, mistakes are not something to fear. They're the key to growth. When a child mistakes an apple for an orange, you don't say you can't learn. Instead, you gently explain the difference. It's the same. Every mistake isn't just an error. It's a valuable insight. A clue that helps the system improve. And what if the child has only seen red apples and doesn't recognize the green ones? His mistakes is a signal that he needs more examples to understand the whole picture. And it's the same with AI. If the model was trained on a limited set of data, it may not understand new, non-standard examples. Mistakes don't just happen, they drive improvement. When the child correctly names small food but still mixed up pears and apples, they get gentle correction. This hint shows where there's still some confusion. AI work the same way. Each mistake helps the model refine its understanding, guiding towards a more accurate path. Step by step, just like learning in real life. So, mistakes are not weakness. They are stepping stones to perfection. They help both people and AI models improve with every step. Now let's bring it all together with another example, recognizing handwritten numbers. One of the most famous datasets for this task is NIST. It contains thousands of images of digits from 0 to 9, each labeled with the correct answer. Let's see how AI learns from this example, just like a child learning to read numbers for the first time. Imagine that you have an album of cards with handwritten numbers drawn on them. Each card contains a number, for example 3 or 7, and its name. A child seeing a number card for the first time. At first they might confuse numbers like 1 and 7 because they haven't yet learned the unique features of each digit. In the same way, an AI model starts with a random setup and might initially think of it the number 5 looks like a 6. It's a part of the learning process, both for kids and for machines. As soon as the child said the number incorrectly, you explain, "Look, there is a slash in the number 7, there is not in 1. This helps in understand where it made a mistake. The AI model does the same thing. After it makes a mistake, the system compares its answer with the correct answer and calculates how wrong the prediction was. After getting feedback, the child focuses on the key features of the number. The next time they see a singular card, they will remember the details and most likely name the number correctly. In the same way, the AI model adjusts its settings. It remembers its mistakes and learns to focus on the important features, like the curves and lines of each number, to correctly distinguish them. The more number cards a child looks at, the more confident he will be in recognizing them. With each new mistake, he received useful feedback and becomes more accurate in his assumptions. In AI training, this process is repeated thousands of times. The model goes through countless images, adjusts prediction based on the feedbacks it gets, and over time it gets better and better, gradually achieving high accuracy and recognizing numbers. So, just like children gradually learn to accurately recognize numbers, AI models learn from their mistakes. With each new example and feedback, the model gets closer to perfection, until it can recognize even handwritten numbers from different people. And this isn't just about numbers. The same learning process is applied to face recognition, speech processing, object detection in images, and even recommendation systems. Mistakes are not failures, they are the lesson that fuel growth and improvement. The more mistakes, the faster the system evolves and becomes more accurate. This is the power of learning through feedback. Like, subscribe, Eugene was with you, see you again.